Coordination compounds. Exercise pages 207 to 209. Exercise Q1.1, page 207. Choose the most correct option. The oxidation state of cobalt ion in the complex Co-NH3, 5 bridge SO4 is underscore 1, plus 2, 2, plus 3, 3, plus 1, 4, plus 4. Solution. The oxidation state of cobalt ion in the complex Co-NH3, 5 bridge SO4 is plus 3. Exercise Q1.2, page 207. Choose the most correct option. IUPAC name of the complex PTN2SCN2 2 plus is underscore 1. Bis ethylene diamine dithiocyanatoplatinum IV ion. 2. Bis ethylene diamine dithiocyanotoplatinate IV ion. 3. Dicyanatobis ethylene diamine platinate IV ion. 4. Bis ethylene diamine dithiocyanatoplatinate IV ion. Solution. IUPAC name of the complex PTN2SCN2 2 plus is bis ethylene diamine dithiocyanotoplatinum IV ion. Exercise Q1.3, page 207. Choose the most correct option. Formula for the compound sodium hexacinaphorate 3 is underscore 1. Na-Fe CN6. 2. Na-2Fe CN6. 3. Na-Fe CN6. 4. Na-3Fe CN6. Solution. The formula for the compound sodium hexacinaphorate 3 is Na-3Fe CN6. Exercise Q1.4, page 207. Choose the most correct option. Which of the following complexes exist as cis and trans isomers? 1. CrNH3, 2Cl4. 2. Co-NH3, 5 bridge 2 circle plus. 3. PTCl2 bridge 2, 2, square planar. 4. FeCl2 NCS2, 2 tetrahedral. 1. 1 and 3. 2. 2 and 3. 3. 1 and 3. 4. 4 only. Solution. 1 and 3. Exercise Q1.5, page 207. Choose the most correct option. Which of the following complexes is chiral? 1. Co-N2Cl2, circle plus. 2. PTNCl2. 3. CrC2O4, 3, 3. 4. Co-NH3, 4Cl2, circle plus. 1. 1 and 3. 2. 2 and 3. 3. 1 and 4. 4. 2 and 4. Solution. 1 and 3. Exercise Q1.6, page 207. Choose the most correct option. On the basis of CFT, predict the number of unpaired electrons in CRF6 3. 1. 1. 2. 2. 3. 3. 4. 4. Solution. 3. Exercise Q1.7, page 207. Choose the most correct option. When an excess of AgNO3 is added to the complex, 1 mole of AgCl is precipitated. The formula of the complex is underscore 1. COCl2 NH3 4 Cl. 2. COCl NH3 4 Cl2. 3. COCl3 NH3 3. 4. Co-NH3 4 Cl3. Solution. When an excess of AgNO3 is added to the complex, 1 mole of AgCl is precipitated. The formula of the complex is COCl2 NH3 4 Cl. Exercise Q1.8, page 207. Choose the most correct option. The sum of coordination number and oxidation number of M and Mn2C2O4Cl is underscore 1, 6, 2, 7, 3, 9, 4, 8. Solution. The sum of coordination number and oxidation number of Mn2C2O4Cl is 9. Exercise Q2.1, page 208. Answer the following in 1 or 2 sentences. Write the formula for tetramine platinum 2 chloride. Solution. PTNH3, 4Cl2. Exercise Q2.2, page 208. Answer the following in one or two sentences. Predict whether the CrN2H2O2 complex is chiral. Write the structure of its enantiomer. Solution. I. The complex CrN2H2O2 is chiral. E. Structures of enantiomers. Exercise Q2.3, page 208. Answer the following in one or two sentences. Name the Lewis acids and bases in the complex PTCl2NH3 Solution. Lewis acid. Platinum 2 ion, Pt2+. Lewis bases. Chloride ion, Cl, ammonia, NH3. Exercise Q2.4, page 208. Answer the following in one or two sentences. What is the shape of a complex in which the coordination number of the central metal ion is 4? Solution. A complex with coordination number 4 has a tetrahedral or square planar structure. Exercise Q2.5, page 208. Answer the following in one or two sentences. Is the complex CoF6 cationic or anionic if the oxidation state of cobalt ion is +3? Solution. If the oxidation state of cation CoF6 is +3, then the charge on complex would be -3. Hence, the given complex would be anionic. Exercise Q2.6, page 208. Answer the following in one or two sentences. Consider the complexes CuNH3, 4PtCl4, and PtNH3, 4CuCl4. What type of isomerism these two complexes exhibit? Solution. The complex CuNH3, 4PtCl4, and PtNH3, 4CuCl4 exhibit coordination isomerism. Exercise Q2.7, page 208. Answer the following in one or two sentences. Mention two applications of coordination compounds. Solution. Application of coordination compounds are as follows. I. In biology, several biologically important natural compounds are metal complexes. They play important role in a number of processes occurring in plants and animals. For example, chlorophyll present in plants is a complex of Mg. Hemoglobin present in the blood is a complex of iron. E. In medicines, A. Pt complex, cisplatin is used in the treatment of cancer. B. EDTA is used for the treatment of lead poisoning. E. To estimate the hardness of water. Hardness of water is due to the presence of Ca2+ and Mg2+ ions. The ligand EDTA forms stable complexes with Ca2+ and Mg2+. It can, therefore, be used to estimate hardness. IV. In electroplating, usually, stable coordination complexes on dissolution dissociate to a small extent and furnish a controlled supply of metal ions. The metal ions, when reduced, clump together to form the clusters or nanoparticles. When the coordination complexes have used the ligands in the complex, keep the metal atoms well separated from each other. These metal atoms tend to form a protective layer on the surface. Certain cyanide complexes K-Ag-CN2 and KO-CN2 find applications in the electroplating of these noble metals. Exercise Q3.01, page 208. Answer in brief. What are bidentate ligands? Give one example. Solution. Bidentate ligands. The ligands which bind to central metal through two donor atoms are called bidentate ligands. E.g. 1. Ethylene diamine binds to the central metal atom through two nitrogen atoms. 2. Similarly, oxalate ligand utilizes electron pair on each of its negatively charged oxygen atoms on linking with central metal. Exercise Q3.02, page 208. Answer in brief. What are the coordination number and oxidation state of the metal ion in the complex PTNH3, Cl5? Solution. In complex PTNH3Cl5, the coordination number of the metal ion is 6, and the oxidation state of the metal ion is +4. Exercise Q 3.03, page 208. Answer in brief. What is the difference between a double salt and a complex? Give an example. Solution. A double salt dissociates in water completely into simple ions, whereas a coordination complex dissociates in water with at least one complex ion. E.g., Moore's salt, FeSO4NH4 2SO4.6H2O is a double salt while K4FeCN6 is a complex. Exercise Q 3.04, page 208. Answer in brief. Classify the following complexes as homoleptic and heteroleptic: CuNH3, 4SO4. CuN2H2O, Cl, 2 circled plus, Fe-H2O, 5 NCS, 2 circled plus, tetramine zinc 2 nitrate. Solution. I. Homoleptic complexes. CuNH3, 4SO4, tetramine zinc 2 nitrate. E. Heteroleptic complexes. CuN2H2O, Cl, 2 plus, Fe-H2O, 5 NCS, 2 plus. Exercise Q 3.05, page 208. Answer in brief. Write formulae of the following complexes. A. Potassium aminotrichloroplatinate 2. B. Dicyanorate I ion. Solution. I. KPTNH3Cl3. E. OCN2. Exercise Q 3.06, page 208. Answer in brief. What are ionization isomers? Give an example. Solution. Isomers that involve the exchange of ligands between coordination and ionization spheres are called ionization isomers. E.g., Co-NH3, 5SO4 bridge and Co-NH3, 5 bridge SO4. Exercise Q 3.07, page 208. Answer in brief. What are the high-spin and low-spin complexes? Solution. I. High-spin complexes. When crystal field splitting energy is greater than electron pairing energy, the complexes formed are high-spin complexes. E. Low-spin complexes. When crystal field splitting energy is smaller than electron pairing energy, the complexes formed are low-spin complexes. Exercise Q 3.08, page 208. Answer in brief. COCl4-2 is a tetrahedral complex. Draw its box orbital diagram. State which orbitals participate in hybridization. Solution. I. Box orbital diagram of COCl4-2. E. 1,4s and 3,4p orbitals participate in hybridization. Exercise Q 3.09, page 208. Answer in brief. What are strong field and weak field ligands? Give one example of each. Solution. I. Strong field ligands. Those ligands which cause larger splitting of d orbitals and favor pairing of electrons are called strong field ligands. Strong field ligands contain C, N, and P as donor atoms. E.g., CN, NCS, Colorado, New Hampshire 3, EDTA, and ethylene diamine. E. Weak field ligands. Those ligands which cause lower splitting of d orbitals, i.e., increment degree parameter is smaller compared to the energy required for the pairing of electrons, are called weak field ligands. Weak field ligands contain halogen, O, and S as donor atoms. Exercise Q 3.1, page 208. Answer in brief. With the help of the crystal field energy level diagram, explain why the complex CrN3 3 circled plus is colored. Solution. I. The central metal ion titanium has electronic configuration 3d3 and the electrons occupy one of the T2 grams orbitals. D. D transition in D system. E. The absorption of the wavelength of light promotes an electron from the T2 grams level to Eg level. Therefore, in the complex CrN3 3+, DD transitions are possible. Hence, the complex is colored. Exercise Q 4.1, page 208. Answer the following question. Give valence bond description for the bonding in the complex VCl4. Draw box. Diagrams for the free metal ion. Which hybrid orbitals are used by the metal? State the number of unpaired electrons. Solution. I. The oxidation state of vanadium is +3. E. Valence shell electronic configuration of free metal ion, V3+. E. The number of Cl ligands is 4. Therefore, the number of vacant metal ion orbitals required for bonding with ligands must be 4. IV. 4 orbitals on metal available for hybridization are 1s and 3 4p. The complex is tetrahedral. V. The 4 metal ion orbitals for bonding with Cl ligands are derived from the sp3 hybridization. V. 4 vacant sp3 hybrid orbitals of V3+ overlap with 4 orbitals of Cl ions. V. Configuration after complex formation would be V. The complex has 2 unpaired electrons. The structure of VCl4 is Exercise Q 4.2, page 208. Answer the following question. Draw a qualitatively energy level diagram showing d'orbital splitting in the octahedral environment. Predict the number of unpaired electrons in the complex Fe(Cn) 6,4. Is the complex diamagnetic or paramagnetic? Is it colored? Explain. Solution. I. Diagram. E. There are no unpaired electrons in T2 grams orbital, hence, the complex is diamagnetic. E. In the complex, dd transitions do not occur and hence, it is colorless. Exercise Q 4.3, page 208. Answer the following question. Draw isomers of the following. PTNH3, 2ClNO2. Solution. Cis and trans isomers of point NH3, 2ClNO2. Exercise Q 4.3, page 208. Answer the following question. Draw isomers of the following. Ru NH3, 4Cl2. Solution. Cis and trans isomers of Ru NH3, 4Cl2. Exercise Q 4.3, page 208. Answer the following question. Draw isomers of the following. CrN2, bridge 2, circle plus. Solution. Cis and trans isomers of CrN2, bridge 2, circle plus. A. Cis and trans isomers of CrN2, bridge 2 plus. B. Optical isomers of CrN2, bridge 2 plus. Exercise Q 4.4, page 208. Answer the following question. Draw geometric isomers and enantiomers of the following complex. PTN3, 4 circle plus. Solution. PTN3, 4 plus shows only enantiomers as follows. Exercise Q 4.4, page 208. Answer the following question. Draw geometric isomers and enantiomers of the following complex. PTN2, ClBr, 2 circle plus. Solution. A. Geometric isomers of PTN2, ClBr, 2 circle plus. B. Enantiomers of PTN2, ClBr, 2 circle plus. Exercise Q 4.5, page 209. Answer the following question. What are ligands? What are their types? Give one example of each type. Solution. In the coordination compound, the species surrounding the central metal atom or ion are called ligands. Depending upon the number of electron donor atoms present, ligands are classified as I. Monodentate ligands. A monodentate ligand is the one where a single donor atom shares an electron pair to form a coordinate bond with the central metal ion. E.g., Cl, OH, Cn, etc. E. Polydentate ligands. A polydentate ligand has 2 or more donor atoms linked to the central metal ion. Based on the number of donor atoms, polydentate ligands are further classified as A. Bidentate ligands. The ligands which bind to central metal through 2 donor atoms are called bidentate ligands. E.g., 1. Ethylene diamine binds to the central metal atom through 2 nitrogen atoms. 2. Similarly, oxalate ligand utilizes electron pair on each of its negatively charged oxygen atoms on linking with central metal. B. Hexadentate ligands. The ligands which bind to central metal through 6 donor atoms are called hexadentate ligands. E.g., ethylene diaminotetraacetate ion (EDTA) 4 binds to metal by electron pairs of 4 oxygen and 2 nitrogen atoms. E. Ambidentate ligands. The ligands which have 2 donor atoms and use the electron pair of either donor atoms to form a coordinate bond with the metal ion are called ambidentate ligands. E.g., A. The ligand links to the metal ion through nitrogen or oxygen. B. SCN has 2 donor atoms, nitrogen and sulfur, either of which links to metal M left pointing arrow SCN or M left pointing arrow NCS. Exercise Q 4.6, page 209. Answer the following question. What are cationic, anionic, and neutral complexes? Give one example of each. Solution. On the basis of charge on complex ion, coordination complex is classified as I. Cationic complex. A positively charged coordination sphere or a coordination compound having a positively charged coordination sphere is called the cationic complex or cationic sphere complex. E.g., ZnNH3, 4, 2+. E. Anionic complex. A negatively charged coordination sphere or a coordination compound having a negatively charged coordination sphere is called an anionic complex or anionic sphere complex. E.g., Fe(Cn) 6, 3. E. Neutral sphere complexes. A coordination complex that does not possess a cationic or anionic sphere or neutral complexes of neutral sphere complexes. E.g., NeCO 4. Exercise Q 4.7, page 209. Answer the following question. How stability of the coordination compounds can be explained in terms of equilibrium constants. Solution. The stability of the complex can be explained in terms of K higher the value of K larger is the thermodynamic stability of the complex. The equilibria for the complex formation with the corresponding K values are given below. Among the above equilibrium constant data, Co-NH3, 6,3+ is more stable than Ag-CN2 and Co-NH3, 6,3+ because Co-NH3, 6,3+ has higher value of equilibrium constant. Exercise Q 4.8, page 209. Answer the following question. Name the factors governing the equilibrium constants of the coordination compounds. Solution. The stability of a complex or equilibrium constant is governed by I. Charge to size ratio of the metal ion. E. Nature of the ligand.